So here's a word problem using right triangles. This one says that a man standing on the roof of a 60-foot tall building looks down at the building next door. He finds that the angle of depression to the roof of the building next door here is 34.5 degrees. Now notice, angle of depression is always measured from the horizontal. So from a line horizontally straight out from the roof of this taller building, and then measure rotating downward this way. This is the 34.5 degree angle of depression to the roof of the building next door, right here, this angle in blue. And then the angle of depression to the sidewalk at the base of the building down here is 63.2 degrees. Again, measured from the horizontal, rotating downward, 63.2 degrees here. We want to find the height of this building next door. So we want to find this length right here. And we're going to have to find that by finding other quantities first. We can't find that directly, I don't think. But what we can do, so we do know this length here, because this is a 60-foot tall building. So I'm going to draw the 60 feet here. This would also be 60 feet. If this is a line straight out horizontally from the roof of the building, then this length right here would also be 60 feet. So if I know this length here, and we know this angle, 63.2 degrees, let me draw that again over here. So we've got 60 feet. Here's this line straight across from the taller building. And we have this angle of depression to the base of this opposite building that is 63.2 degrees. So using this angle, we could find this distance here. I'll call this x. Because, let's see, so the 60 feet, that's opposite of this 63.2 angle of depression. This is the opposite side. The x right here, this distance is the adjacent side. Because this is a right angle right here. And so the side opposite of the right angle, this is the hypotenuse. So now we're dealing with opposite and adjacent. So if you go back to the SOHCAHTOA, opposite and adjacent, so we want to use the tangent function right now. Tangent of 63.2 degrees would be equal to the length of the opposite side, which is 60 feet, over the length of the adjacent side, which would be x. That's going to be this distance across the street from one building to the other one. So now we could solve for x by what I would do is multiply by x to get it out of the denominator. So that's going to cancel there. And then divide by tangent of 63.2 degrees on both sides. Tangent of 63.2 degrees. And so we end up with x equals 60 divided by tangent of 63.2 degrees. And so now we could grab a calculator, make sure you're in degree mode, and get the value for x. And I think I do want to go ahead and evaluate that. I know in general it's best to wait till later, but I don't want to make this more complicated than it already is. So 60 divided by tangent of 63.2 degrees gives us 30.3. I'm going to grab a couple of other extra decimal places on this. So x is approximately 30.308. And it goes on from there. Okay, but so we know now that this distance, x, right here, is approximately 30.308 feet. Now I want to use that to help get the height of the building. I'm still not ready to find this height directly because I need to use right triangles. Whatever triangles we use in this section have to include a right angle. But what if I focus on this blue triangle at the very top? I could use this blue triangle to find this distance right here. And if we have this distance, let's say it's 20 feet, then we could just take 60 minus 20 to get the height of this building. So that's my plan. Use this upper triangle to find this extra bit of height, and then subtract that from the height of our taller building, which is 60. And that'll give us the height of this shorter building, which is across the street. All right, so we used this red triangle out here to find the distance between, this horizontal distance between these buildings. We know now it's about 30.3 feet. So I'm going to get rid of this work here. I think I'll get rid of some of the words here too. Give us a little extra room. So using that blue triangle, let me see if I can make this a little darker. Up at the top of the building. So now we have this X is approximately 30.308 feet. We know this angle is 34.5 degrees. And I want to find this distance here. I'll call it D for distance. So again, this is the opposite side. This is the adjacent side. Opposite and adjacent. I'm going to use the tangent function. Tangent of 34.5 degrees equals the length of the opposite side, which is D, over the length of the hypotenuse, which is 30.308. And so if I multiply by that 30.308 on both sides, this will cancel. 30.308 on this side. That'll give us this extra bit of distance. So let's see. 30.308 times tangent of 34.5 is 20.8. So about 20.8 feet is equal to D. And then let me draw this diagram again. Wow. So we've got this taller building and then the shorter building. We found out that this was our D. This extra bit of height is about 20.8 feet. And I know that this building is 60 feet tall. So to find this height right here, we can do 60 minus the 20.8. Let me keep this color-coded. 20.8 gives us, 60 minus 39.2. So this building is about 39.2 feet tall, this shorter building.